Yes, it's SDL. Once again, school started and all kinds of crazy things happened. Russ came back from like the great beyond where he was, and he's going to be with us again today. You asked for it, you got it. So today on SDL, we're going to talk about all those things you've been wanting to hear about, like crypto keys and digital certificates. If we didn't have them, everything would be sent in a clear, so stick around.
This is a Security Weekly production.
Welcome to Secure Digital Life. If your users are going to keep putting risky stuff on your machine, you're screwed. So, Tom can help us understand the complexity of blockchain.
I was reading through the show notes, man. Oof.
In binary, it would be 001. Who cares? But it's probably not significant anyway. Like you're looking out through the HAL dot, you know, like,
oh,
hey, Dave.
It's like Sim, but with, you know,
it would be like Sim.
Instead of AI, it's only.
Accredited by Microsoft, Cisco, NetApp, IDLE, Oracle, and EC Council, QuickStart delivers high-impact, low-cost IT training through its cognitive learning platform in multiple domains. With QuickStart, you get an ever-growing catalog of courses, self-paced courses offered through a monthly subscription, virtual classrooms offered through an annual subscription, peer-to-peer learning, mentoring, official courses, certified instructors, hands-on labs, and more. For more information, visit www.quickstart.com. Use coupon code PAUL20 to get 20% off on all cybersecurity courses. QuickStart, creating world-class technologists. Yes. So you, and only you, should check out our on-demand material because it's there. And I mean, why not? Some of our previously recorded webcasts are now available on demand at securityweekly.com/on-demand, as you might have guessed. So welcome back, Russ, from the great beyond.
Yeah, thanks. And welcome back to you, too, from Vegas. You know, we were both there, but on opposite sides of the week. So
yeah, I was on the good, wholesome side of Vegas. I know where you were. Yeah, it was like you were on that other week doing those other things. I was over there where we were like, you know, doing wholesome activities like knitting and things like that at the pool at Caesar's Palace, which is like all about, you know, like good, wholesome, clean, red-blooded American fun or something like that. Yeah, we had fun. Did you have fun in Vegas?
Yeah, my friend and I had a great time.
I haven't seen you since we were in France, I think. So
I know. That was a long time ago. And yesterday, by the way, everyone online, was Doug's birthday. Woo,
well, that's true. It was, yeah. So it was. So I'm even older now, but that's okay. And then I have to try to catch up on saying thank you. So I was going to write a script for that, but I can write a Python program to go through and do it. But today we're going to talk about crypto, not Python. We'll talk about Python one day soon too. I think I've got that on my list of things to talk about because we're answering your questions that you've been writing in. So if you have a question, you should write it. We want to talk about crypto a little bit. And crypto is one of those things that, like when I was teaching a lot of boot camp classes, everybody can't wait to get to the part of the class which is about crypto. And then they get to the part about crypto and they run like hell because, you know, math and all that. But crypto is about math, but it doesn't have to be to understand the basics of it. And we don't have to do a lot of math if we just want to know kind of what's going on. And so today we were going to talk about like what's happening. Have you ever done crypto, Russ? Have you ever done work with that?
I studied it a little bit in school. We did like simple Caesar ciphers in an aesthetics class, and then in the more math and encryption areas, we did stuff like that too. So,
well, I mean, crypto has been going on for thousands of years. I mean, I'm sure before the Romans, you know, the Sumerians and the Mesopotamians, and everybody always did all kinds of tricky things to hide messages or orders for troops or all those kind of things. The Romans are kind of famous for it because I guess maybe the people started documenting things then, but I know the Romans used this thing with like a rod. So they had this rod that was of different sizes and they wrapped little strips of paper around it or papyrus or whatever they were using, and they wrapped it around there, and the size of the rod determined how you started the crypto and all these kind of things. And of course, they used what you mentioned, the Caesar cipher, which it was based on just shifting alphabet code. So this is the old, Captain Midnight secret decoder ring. See what's happening, decrypt the ingredients in this box of chemicals that you're eating as breakfast cereal. Sorry, Captain Midnight, but we all ate that, and that's why we're all dying now. But that's okay. But and of course, at those times in history, when almost not everyone, I was reading about this the other day about the rate of illiteracy in the Roman Empire, because I always was saying, well, everybody's illiterate, so just writing something down is a pretty good crypto code. But the truth was that they weren't, the illiteracy rate was not that high. I ended up reading a paper yesterday about from Harvard about like how many people were illiterate and how these people went to school. So, but still, I think that people were not really literate, right? I mean, what do you think, Russ? Were they really literate?
I mean, it really depends. I don't really. I would say that they were not really illiterate. I mean, they just, we could recognize symbols and characters.
Well, there's literate, and then there's like, I can put an X on this piece of papyrus to mark, my name, but there's also sort of like I can manage to read through the word, but maybe I'm not up to like figuring out some kind of word jumble thing. And so I think all those kind of ciphers were pretty sufficient back in, 2,000 years ago and before. Of course, almost all ciphers up until the modern age were symmetric key ciphers. And if you don't know what a symmetric key cipher is, we still use them today a lot. You probably are using one to watch this show right now. But a symmetric key was the idea that I give you the code, or you give me the code, and we know what the code is. And by doing that, we can send each other secret messages. So this was pretty much what most people think of as crypto is about the world of symmetric keys. So everybody's heard about Enigma in World War II. Fewer people have heard about Purple, which was a Japanese code that was broken by the U.S. Navy that let them read Japanese submarine instructions. The code was called Purple. And there was all those things, but they were all based on symmetric keys. Now, they were all shifting symmetric keys. So what happened was the problem with a crypto is if I tell you the key to everything out in the world is that an A equals 7 and a B equals 10 and a C equals 45, and we share that information, very soon somebody figures it out, or somebody starts talking about it in a bar somewhere in Mesopotamia, and the next thing you know, all the other Mesopotamians know about my secret 71045 code. Okay, so that's one of the big problems with symmetric keys. Now, they work. They were very reliable. One of the classic symmetric key schemes that was ever used was to use a book. So a lot of early spying stuff involved handing somebody a book and say, I have the 4th edition of Moby Dick, and you have the 4th edition of Moby Dick, and you take your copy with you off when you go on this mission, and that way when I send you messages, every day we shift a page. So if we start on page 40, and every day we turn a page, and the first 26 letters of that first paragraph in that page determines how that breaks out into a code. That is a really nasty crypto that is very, very effective as long as someone doesn't figure it out. If someone figures it out, the whole thing is shot. But it works. And I mean, and these kind of things actually led to the creation of sort of the most famous types of symmetric key encryption, which were called one-time pads. So in World War II, they had huge cadres of people whose job it was to make these big sheets of crypto ciphers. And each day you used a new one and you tore it off and everybody kept up. And that was a one-time cipher. So because it was a one-time cipher, it was really, really tough to break. In fact, the way they really ended up, if you've ever seen, what's the name of the movie, Russ, about Turing? I can't believe I can't think of it.
I'll Google it real quick.
Well, there was a movie about Turing that came out a couple years ago, and they were talking about Enigma. And one of the secrets to breaking Enigma was the fact that they figured something out, which was that they put Heil Hitler at the end of every order. And when they knew that, then all of a sudden they were able to figure out these crypto schemas, and they were able to sort of backtrack into how all this machine worked, and then they were able to start deriving what was going on.
The imitation game?
Yeah, the imitation game. Sorry, I'm old now. What am I supposed to do? It was my birthday yesterday, so I have an excuse. I'm old. But the problem with the symmetric keys, there's multiple problems with symmetric keys. One of them is it works fine as long as there's 2 people or even 3 or 4 people. But what happens when you start talking about lots and lots and lots and lots of people? And you can share keys, and the way that you traditionally share keys is called out of band. So that means I give you the secret envelope, and you take it with you in your backpack when you go off on your secret mission to Samaria. And, on the right day, you tear the envelope open, and inside is the crypto key, and you got to protect that with your life, or, putting it in bodily cavities or something. I don't know how you do that, and we won't get into it. We were asked to provide an example of that sort of stashing, but we're not going to. So you can rest assured that you will be safe watching this show. So that's the first part of the problem. The more people you give the key to, the greater the likelihood that it's going to go awry, and somebody's going to lose it, or somebody's not going to stash it where they're supposed to, and it's going to get found. When I used to use symmetric keys when I had a job, and we had an actual plastic card that was issued to us, and you had to break the plastic card open, and you used it one time, and then you threw it in this burn bag, and that was the end of it. Worked fine. The problem started when the internet got rolling. We suddenly had this giant issue of how do we deal with out-of-band keys. So the early internet, everything was sent in the clear. So you go back to 2005 and you look at internet traffic, everything in HTTP, so Hypertext Transport Protocol, is sent straight up in the clear. You can see the letters going by. So you grab all those packets and boom, everything is over. And one of the questions I got asked so much around 2008, maybe 10, was by media people asking me, is it safe to use the internet? Have you ever been asked that, Russ? Did they ask you that kind of question?
Yeah, I have a lot of friends. In fact, you and I have been in situations with my friends who have asked you just that very questions, like, is it safe to use Wi-Fi at Dunkin' Donuts or Starbucks? And the answer is not really. So don't do it. Use your phone, as you would say.
Yeah, and if you looked at a website, so you go back to the early part of the internet, even on into like 2015 and such, most websites were using HTTP as their primary exchange mechanism. And what that meant was that if you typed something in a form on an HTTP-based website, that information you typed in the form was sent across the world to all these different places to get to the other end, and it was sent in the clear. It was ASCII text that anybody could grab and read. And when people asked me that question, I was like, well, you shouldn't be putting information you don't want to share onto web pages. And so people were like, well, so you mean when I go shopping on the internet, if I put my credit card number in, somebody could see it? And I'm like, absolutely they could, because it's being sent in the clear. So all somebody has to do is watch packet streams, watch for 4388, and boom, they own your data. So the internet started trying to fix this. And a protocol called HTTPS, there's an S at the end of it, existed. And so pretty early on, you started to see embedded boxes in web pages that used HTTPS. So all this public data, so all the headlines or whatever, is just HTTP. But you'd see this little box, and the little box is going to be HTTPS. So your data was going to get enciphered when it went across the internet, which means that it's just going to be a bunch of garbage. That was a big problem to solve. How it was solved was using something called an asymmetric key. An asymmetric key encryption is different than symmetric. It's slower. It's a very strange thing, but it's based on, you guessed, math. And somebody came up with what is called a one-way or a trapdoor algorithm. And a trapdoor algorithm means that if you plug something in on this end, the result that comes out the other end can only be decrypted with another thing. It's not the same key. So the key on the left side is not the same as the key on the right side. Ooh. So all of a sudden, this got defined as a public key and a private key. So I could take a public key and give it to anyone that wanted it. And I could say, use this public key. So you're going to encrypt it with this. And I'm going to use this private key to decrypt it. So I'm not going to give anybody my private key, but I'm going to give everybody my public key. So what that meant was that now we could actually find a way to not have to go out of band to exchange information. So if I have the private key, I can decipher things that were enciphered with the public key. And it works the other way as well. So if I encipher something with my private key, anyone with the public key can decrypt it. And you may say, well, what's the point of that? And the answer is, it's called a digital signature. So since I'm the only person holding the private key, if you get something that can be deciphered with my public key, it means that thing had to come with someone who had the private key, which would theoretically only be me. And so that created the advent of what are called digital signatures. And that way I can give a public key out and keep my private key, and you can send me things that are enciphered, and I can decrypt them. I can send you things that are enciphered, and you can decrypt them. And all of a sudden, we had a way that we could operate. Now, the way this is done then, have you ever signed a certificate, Russ?
I have.
Yeah?
And we've actually created some certificates for HTTPS for some of the systems we use here at the university when I worked in IT.
Well, yeah, what Russ was talking about is called self-signing. And so certificates are a weird animal. And basically what happened was initially people started using this asymmetric key approach to signing a digital certificate. So this digital certificate then is signed by a certifying authority, and it creates a public key essentially. And so what happens is if you self-sign it, then it's just sort of you saying, yeah, I'm a good guy. Give me your money. So we realized pretty quickly that self-signing wasn't necessarily the best way to go, because when our audience is just me and you, so I know Russ and Russ knows me, and if he was looking at my website at school, which has a self-signed certificate because I'm too cheap to buy one, he pretty much knows that certificate is on Fans Network, which is the network I support, and he's cool with it. But if he went to some weird website in Azerbaijan and it doesn't have a certificate or it's self-signed, I would say trusting that is a pretty scary thing. What do you think, Russ?
Absolutely, and that's why there are security authorities that do this for you. So yes, I wouldn't say that. Yeah, Doug. Hey, I know Jimmy. He said, I told him to, vouch for me. Will you hire me? Yeah, sure. Okay, great.
Right.
And that's that.
Well, so these certificates then ended up getting used to create what are called hybrid keys, because the idea was symmetric keys are more effective. They're faster. They're really good to encrypt things with, but the problem is, how do we exchange the keys? Asymmetric keys are really easy to exchange the keys, but they're slower. They've got a lot more back-end kind of problems with them, and there's some, flaky kind of stuff with this. So what happened was, in order for the internet to function, because now remember, you've got a one-to-many problem on the internet. I have a server. I want to sell you stuff. I want to sell you whatever it is I'm selling, and we could come up with all kind of racy products, but whatever. I want to sell those products. You want to give me personal information and make sure that it's safe. I also want you to trust me. So I want to say, I'm Amazon. Are you sure it's actually Amazon and it's not some fake website that you're getting ready to buy something from and get ripped off? Okay, so what if I put a public key digital certificate on my website? That public key, private key pair can be used to allow the two servers, meaning one my server and you on your end, whatever you're using, to exchange the public key information. And what's done is then my public key is used to encrypt my symmetric private keys, and I exchange that with you. So there's a sort of little operation that happens. Would you agree with that, Russ?
Yeah, absolutely. Totally.
Okay, so what happens when you go to a website? So today, if you look at almost any website you go to, you'll see that little padlock up in the corner. So you see a little green padlock, and it says HTTPS on the URL. What that means is that when you went to that way, even if it's just a news site or something, and you're not going to give them any personal information, you go to CNN.com, it's all running HTTPS because we have enough bandwidth to handle it now. What happens when you create that session is pretty straightforward. That digital certificate is used to send you a public key. So your system, your browser, gets a public key and encrypts information back using the public key, which can only be decrypted by the private key, right? Same thing happens the other side. Your system sends its public key to the other end, and those two public keys get traded. So now the server is using the public key for you to encrypt everything. Your machine is using the public key for the server to encrypt everything. But the only thing that happens in that session is that it creates a random private key, and then the two devices exchange that random private key through that public key asymmetric encryption. Afterwards, the whole session is encrypted with the private symmetric key. And so this is the out-of-band part. So we send it encrypted across the internet, and that's a pretty handy-dandy kind of thing to do to make work. And I like that idea a lot, and it really facilitated the needs of the internet. Russ, you comment on that?
No, I mean absolutely. The asymmetric encryption is sort of the best way to go. And anyone sitting with a packet sniffer at Starbucks or whatever, I keep targeting them, but wherever, will tell you that the HTTPS over 443 is definitely the way to go,
right,
for modern communication.
And so what happens is the HTTPS component of this uses what is called SSL, which is Secure Socket Layer, and this is a layer 6 protocol that is in the TCP/IP model. And Secure Socket Layer basically is taking each one of those packets, whether it's Netflix or it's your credit card information or whatever it is, when you log into something, all that's being sent and it's wrapped. So we take that and we wrap it in encryption. And that means that if somebody intercepts it, what they get is they get a bunch of garbage. And that garbage can be broken. I'm not going to lie. There are examples of things being cracked. It's certainly possible. But here's the catch. Can you do it fast enough to make it worth your while? And the answer is probably not. I mean, that's sort of where we are right now. So is it possible? Yes, it's possible. It's always possible. Somebody can break it. It can be broken. The problem with it is a lot like a one-time pad. This is a random key. It's random encryption, and it's used for that one session. When you finish that session, it's all gone. And yeah, if there's a hole in the encryption, then they can break it over and over and over again, but that's not the case right now with SSL, at least to my knowledge. So it can be broken like any other type of encryption, but it's going to take some time in order to do that. So what we have is we have asymmetric encryption on one side, we have symmetric encryption on the other side, and by doing that, we allow ourselves to use SSL to create HTTPS secure sessions between two devices. And this is happening a million times. Just a fact, when you went to watch this show, look up at the top of your browser and you'll see that little padlock and you'll see HTTPS. That means that the site is in there. I'm going to talk a little more about how certificates get made in a second, but that means that the site matches. So Security Weekly is what's on the certificate for that, and that your browser did that for you automatically. It validated that. So let's talk a little bit about how these certificates actually then get built. Now, like I said, you can sign these yourself. So you can go on the internet and you can Google how to sign a certificate, and it will walk you right through it. And on a Unix system, it's really easy to do. The problem with that is that then it's just trust. This certificate is signed by Doug. So if you go to dougwhitesucks.com, dougwhitesucks.com has a certificate that was signed by me. Then basically on that site, you don't trust it because anyone can sign a certificate. So how do you get around this problem? Did you buy a certificate, Russ, when you were doing those?
We did. Yeah, we bought it from GoDaddy.
Yeah, so
Secure Bridges.
So an ISP can issue certificates. Basically what happens is a high-level trust authority. So these are called certificate authorities, or CAs. Those high-level trust authorities exist. How did they get to be high-level trust authorities? Beats me. Somebody sat down and decided, who do we trust and who do we not trust? They trust Microsoft? Okay. They don't trust Doug. You figure it out. You trust the Catholic Church? You don't? We're not going there. But, I mean, at the end of the day, somebody decided that certain authorities had a level of trust and certain authorities did not. And today, guess what? This is like that old question where they always ask you in those entry-level classes, they go, who owns the internet? And, you know, the answer is like, no one owns the internet, Doug. And I'm like, you're completely wrong. You lying. No, somebody does own the internet. It's called the backbone providers and the ISPs. They own the telcos, so they can turn it off or turn it on. They own it. And they can make rules. So basically, people like Google with Chrome or Firefox, is that Mozilla? As Mozilla makes Firefox, Microsoft makes their browser, their sad browser.
Apple Safari.
Apple makes Safari. Microsoft. What is Microsoft's called now, Russ?
Edge.
Edge. That's right. And yeah. So the Edge browser. Sorry, there's a little bit of an inside joke going there from Las Vegas, but we won't get into that either because this show is not R-rated. But Microsoft's Edge browser, which keeps giving you those poor little sad messages. I don't know if you've ever seen an episode of Rick and Morty where Rick's got that little robot and it's buttering his toast, and the robot goes, "What is my purpose?" And Rick goes, "To butter my toast." And the robot's just like, "Just kill me." And I think Edge feels like that a lot because Edge is sitting there going, "What's my purpose?" To let me download Chrome. But whomever wrote the browser, and if you write your own browser, you can do whatever you want, but whoever wrote the browser sits down and says, who are we going to trust? And Google says, well, we're going to trust Google, of course. And Microsoft says, well, we're going to trust Microsoft, of course, and IBM and everybody else. So if you want to be a certificate authority, you have to convince enough people to trust you, and then they would allow you to issue a certificate. Now, if you want to issue certificates, you can just issue certificates. But if no one trusts them, what happens is when a browser goes to that site, even if the certificate matches, but the certifying authority on it is Doug, the browser is going to throw up that message that you may have seen on occasion that says, this website is not safe. And I think on Chrome, does it say, get me out of here or something like that?
Yeah, something like that, yeah.
Or you have to click a link that says, I trust this site implicitly, proceed. And then you go to the website and get hosed. But regardless, the way that's being determined is not some elaborate safety algorithm. It's just literally a list of who you trust. And that list is compiled by Google. And Google Chrome division says this is who we're going to build into our trust database. If they don't want to put you in there, they don't like you. And certificates can be revoked. So if you go buy a certificate from whomever, and then they decide that you're not trustworthy, they can actually revoke. So if you want to buy a certificate, typically you have to produce ID, you have to produce that, proof that you own that domain, and so on. So if I put up a domain like edgeofforever.com, so Edge of Forever becomes a domain that I own, and I want to buy a certificate for it, I'm going to go to a CA, and that CA is going to issue a certificate. Do you remember what all goes into those, Russ?
Just the information they asked us. You needed to provide credentials, like you said, that you own the domain, which for the domain issue authority. And the tickets themselves are not really that expensive. I think it was $135 for X number of years, and X was 1 or 2 or 3, somewhere around there. So if you're interested in getting a certificate, you might as well pay the money and get a trusted one. It makes it a lot easier on web browsers. So, and
I keep meaning to do that, but I just never get around to it. So mine is untrusted, but all the people going to that use my certificate know what they're getting into. So it's just and
some corporations actually block untrusted sites. So by domain policy. So it may be worth your while to pay the money to get that.
Well, if you want strangers to come to your site, meaning you don't control that. So like my thing that I have a certificate on, it's only people that would need to be there who know me. So they're students that are going into that OpenVPN or whatever. So I don't worry about it too much because this is a case where I control the access and I control the people. But if you're trying to set up a company like edgeofforever.com and you want strangers to be able to get to your site, they may well be blocked. Most companies do block unregistered domains, and they block non-certified domains at this point. Now, that self-signed certificate still encrypts all the traffic. But what it doesn't do is ensure that there's a level of trust that's been issued to me by CA. So if I want to buy that, I have to go to GoDaddy or whomever, and you can get it from wherever you want. But they're going to issue that certificate for the domain. So your ISP can very likely sell you the certificate and allow you to create it. So you're going to go in there and create it with the domain name. It's got the fully fledged domain name. So it's got every little piece of it has to match. And then you add some pieces to it that make it unique, like where it's located and all these kind of things. And that creates this unique digital certificate that you would then slap on your website. so that you can use SSL encryption for HTTPS. Today, I would say not using HTTPS is going to put you in a minority based on all the public sites that I go to. I was just looking at them yesterday, and I went to a whole bunch of different ones, and they all were using full-blown HTTPS. That changed a lot in the last 2 years. 2 years ago, most of the time what you would see is HTTP, and then there's subsets being used in the web pages. Not true today. Because the bandwidth increased, because it's not that big of a speed issue, now you're just basically seeing everybody going full out HTTPS. Why bother? We might as well encrypt everything. Last thing on this, once you have HTTPS, you put that over a VPN. So we always tell you should be using a VPN. That means that the encrypted packets, the SSL encrypted packets, are encrypted again. So the VPN is putting another wrapper around it. So now somebody who wants to see this stuff has to break the VPN, then they get all the encrypted packets from HTTPS, and then they got to break a different kind of encryption to get into that. So that is pretty reasonable, I think. You know, if it's national security, if it's really dangerous stuff, then yeah, I would be worried. But if you're just, you know, surfing the internet, I would say that that's a pretty safe bet. The last thing I want to tell you about that, though, that's really, really important. Remember, none of this protects you beyond the endpoints. And I have to tell you what that means. On your computer, the encryption doesn't start until that leaves your stack. That means when it goes out on the wire. So that means if you have a lot of personal information on a public computer that's sitting there, HTTPS does nothing to protect you on that side. So that means that all that data is still laying there. And if somebody else sits down at that computer, that stuff may be in a cookie, it may be in the browser. So you've got to use secure browsing, and you've got to be careful. It does not protect you from downloading bad things. They'll be downloaded safely. So that malware you just clicked on is going to download encrypted, and nobody can read it. But once it gets on your end, the encryption is gone, the SSL is gone, and it's just a raw packet on your end. The other one is on the other end. If you send data to someone, it is encrypted out on the internet. That means people looking at the internet don't see it. That means that it's encrypted, it's wrapped in maybe double encryption. But when it gets to the other end, it gets unwrapped. And that means if you send all your personal information and your nude photos to somebody on the other end, once it gets there, the person that has access to that server may well have access full on to that data. So it's being stored in a really lame database that anybody can access, who knows. So you really need to be careful. And those certificates do not, that trust in the certificate only validates that that person is who they say they are. That's it. That doesn't mean that they're trustworthy. It just means that that website is what it says it is. If it says that it is edgeofforever.com, that's what it is. Beyond that, you got me, and I don't know. Russ, you have any other comments about that?
No, I think it's very important that you made that comment about the point-to-point, and really it's just sort of for you know, spying eyes on the internet that this helps with. If either system on each end is compromised, then you know this can't help you. Yeah.
Right, and your data may be being stored, and that's a bigger concern. So I have had people ask me, say, oh, I'm using a VPN. I mean, I'm safe, right? And I'm like, well, what are you connecting to? And they're like, oh. I'm like, oh, come on, you can tell me, I'm a doctor. And it's like, okay, it's like really disgusting pornography. And it's like, okay, yeah, your data is on a porn site, and you know, yeah, it's a big problem. So I've been asked those questions a lot. So you can ask me, you can tell me, it's safe. But thanks for listening to us talk about SSL and certificate encryption today. Don't forget to send your questions into SDL if you have stuff you want us to talk about, because we love to get new topics that you want to hear about. And thanks for joining us, and we'll see you next time on Secure Digital Live.